Thanks all for joining this session today. Really appreciate your time and for picking this session over the other wonderful sessions happening at the same time. So really appreciate that. My name is Grace Jansen. Hi, it's lovely to meet you all. This is my first time in Malmo. Not my first time in Sweden, been to Stockholm a few times, but first time in Malmo. So I'm excited to meet new people, see a new place, and get to speak to you today. So I work at IBM in the UK. If you couldn't tell from my accent, kind of gives it away. But yeah, I've been there for 7 years now, working as a developer advocate in the Java space. Before that, I did a biology degree, because the two go really well together. And actually today I'm going to be pulling those two passions together. So biology and computer science and sort of developing cloud-native applications to hopefully show you how we can learn from the world of medicine to hopefully apply that to our cloud-native applications when it comes to our observability. So, what can we learn from medicine? So when it comes to medicine, it's really a discipline that takes years of study and dedication to be good at. You know, doctors spend hours and sort of decades of their time, really, figuring out how to be able to diagnose using lots of different metrics. It could be physical symptoms, it might be a written note, it might be a medical history. We can also use live metrics. It might be a heart monitor, an oxygen monitor. Lots of different biometrics that doctors collect to be able to accurately diagnose. And we do exactly the same thing in software. In software, if things go wrong, we immediately start looking at our metrics. It might be CPU usage, memory usage, API calls. It might be network traffic. There's lots of different metrics we use in computer and sort of in cloud-native applications as well. But the difference between medicine and where we're at the moment with cloud-native applications, or at least often I find the majority of cloud-native applications, is sort of this difference that we find between, as a doctor, if I was diagnosing an adult, it's really different to diagnosing a baby. And that's because we're missing this all-important context of context, being able to communicate. So because babies aren't able to communicate with us what's happened before, what's going to happen after, maybe events that might have occurred that might have led to those symptoms. As an adult, if I turn up to the hospital saying, oh, I've got a bit of a headache, but I've had a tumble the day before and I've fallen over, it's probably just because I fell over. It's probably not a big deal. But you know, worst case scenario, that could potentially be a life-changing cancer, tumor. It could be a lot of different things. So the same symptoms can have drastically different diagnoses without that all-important context. And that's often what we're missing when it comes to cloud-native observability is we get a piece of information, but we don't get all the context around it and how it interacts in terms of that sort of distributed path that it's taking through what's often multiple microservices. So that's what we're going to take a look at today. How can we start to utilize context in our cloud-native observability to become more like the doctors we see in medicine and to become a cloud-native doctor? So to do this, we're going to be taking, that's broken, back to the classic old-fashioned way. So we're going to be taking a look at observability today. And to do that, we're going to take a look at sort of the theory behind what we're trying to achieve here in terms of cloud-native applications. We're going to then take a look at some of the open source software and technology we can use for that. And then we're going to take a look at a live demo. If the demo gods love me, we'll have to see. So, theory first, because I like to make sure everyone's on the same level playing field here. Okay, so when it comes to implementing observability in our cloud-native applications, theoretically, it's fairly simple. Actually putting it into practice is something different, but theoretically, it's not too much to handle. There are 3 key steps. The first step is instrumentation. So enabling our applications and our systems to be able to actually collect the data that we want to be able to use. So that might be logs, metrics, traces, lots of other data to collect. The second step is once we've enabled our systems and our applications to actually collect that data, is we need to send it somewhere, because it shouldn't be the application's responsibility. So we want to send it to a separate external system that can then store and analyze it. And you might already be doing this with tools like Jaeger, Zipkin, whatever it is that you might be using. Step 3, Once we've stored and analyzed it, it's all well and good having data, it's all well and good storing data, but we need to understand that data. So we need to be able to provide things like visualizations, insights, query capabilities, to be able to actually humanize that data, so that we as developers can understand what's actually going on, what might be going wrong, and be able to fix that. So again, you might be using existing tools already, things like Prometheus, Grafana, Kibana. There's lots of different tools out there that you can already make use of for step 3. Now, you'll be pleased to know, in the 40 minutes we have, we're not covering all of this, because that would be like a whole day workshop. So don't panic. We're just going to be focusing on the first step, instrumentation. So how do we effectively instrument our applications to be able to collect the data we need? And to do this, there are 3 key pillars. We've got logs, we've got metrics, and we've got distributed traces. Now, this isn't to say this is the only data you should ever collect, or the only data that matters to be highly observant of your systems. There are other data you can collect, so things like end-user monitoring, so being able to gain real-time visibility into that user experience. There's also profiling, so being able to understand where our code spends the most amount of time, and also where does the CPU go, right down to the individual line number is what profiling can offer. But for just now, again, in the interest of time, we're just focusing on those core 3, which is logs, metrics, and distributed traces, which are the core 3 that are identified in most observability frameworks and tools. So the first of those is logs. Now, I'm not going to spend too long on this, because hopefully everyone in here is logging. I'm seeing some smiles. So logs by far are the easiest to generate. They are used prolifically across software engineering. And they perform really well in terms of surfacing that sort of higher level, higher granularity level of information, so long as the sort of search space is localized to events that occur in just a single service. However, there are disadvantages to excessively logging. So we want to make sure that we're doing it sort of in the right amount, because excessively logging does have the ability to affect things like application performance. So there is a balance to be struck, but logging can be really useful for that high granularity. And most sort of application frameworks, languages, libraries, they all have the ability to be able to log. So you're probably already using this one. I'm hoping most of you are already using metrics. So metrics kind of take that one step further. The thing about logs is they tend to be a single time-stamped message or event that occurs, whereas the great thing about metrics is that we can collect information over a period of time. So it's much better in terms of being able to mathematically and statistically transform that to be able to see trends over that period of time, to understand what's the normal for my application and when is it not performing normally. That might be things like, oh, goodness, is everyone okay? You all right? Excellent. Safety first, guys. So metrics are really great to be able to have that sort of trend over a period of time, and being able to understand things like events that might occur. You might be triggering alerts based on metrics, for example. So it makes it really sort of better suited to giving us the overall health of a system. The biggest drawback, I would say, of only using logs and metrics is that both of these are system scoped. So it makes it hard to be able to understand anything that actually occurs other than in that particular system. So things like logs, for example, without fancy joins between them, it doesn't give us much information about what happened to a request across all of the components of your system. So we need to take it a step beyond that. We can't just be relying on logs and metrics, and that's where distributed tracing comes in as that third pillar. So distributed tracing, some people just refer to it as tracing. I say distributed because what we're really talking about in this session is cloud-native applications, so distributed systems, often with many different microservices spread out in a cloud-native architecture. So distributed tracing is really about recording the path taken by requests. So it's kind of tracing this path, hence the name, as it moves from one service to another. And it allows us to be able to really narrow down and pinpoint specific errors or bottlenecks within individual services that might be negatively affecting the whole overall system. So without tracing, it can be really difficult to be able to specifically pinpoint those errors and performance difficulties that you might be having, especially in a distributed system. So it helps us to be able to really improve the visibility of the health of our system and enables, importantly, us to debug that potential issue. So tracing might be the one that you might be sort of newest to in terms of those 3 key pillars. In terms of tracing, there are 3 key concepts, and tracing is really where I'm going to focus the demo today. Now, the open source tools and technologies I'm going to be introducing also allow logs and metrics. So if you're interested in that aspect, you can still use these tools, but I'm going to be focusing on tracing. So when it comes to tracing, there are kind of 3 key elements that I wanted to make sure we were all sort of aware of and understanding before we continued with the demo. So when it comes to tracing, you have traces and you have spans. Traces represent the requests, and they normally consist of multiple spans. So in my diagram here, I've got an orange line at the bottom that represents that trace going all the way along. So as my requests are going through multiple different microservices in my distributed architecture. And then those are consisting of spans. So a span is essentially just a piece of work that occurs within a particular service in a request. So normally a span contains things like name, some time-related data, log messages, metadata, and they can be sort of really useful for understanding what that piece of work was and allowing us to be able to collect together that request through those multiple services. So, in this diagram, I should say, they are represented by the sort of pinky ready boxes in each of my microservices. But the thing that really sets tracing apart is this concept of context. So context is what allows us to be able to sort of go more towards what we see in medicine of being able to understand where this fits in terms of our system. What's gone on before, what's gone on after, why has something gone wrong, not just what's gone wrong. So far, what we've identified is just the components of a trace, but this is how they're linked together. So this is why context is important. It tends to be an immutable object, and it normally consists of 2 values. You've got the parent ID, and you've got the span ID. So I've put those in my diagram here. Context at the bottom is that sort of middle section in purple there, just to show you how they link together the different spans. So the trace ID in context is essentially the unique identifier that's generated right at the very start of a request. So it allows us to be able to know all of these spans are part of the same trace, hence having the same trace ID. The second thing is the parent ID. The parent ID, you have to listen to this one, is the span ID of the parent that spawned the current operation. That was clear, right? That's why I've got a diagram, okay? So in here, you can see the parent ID on the first bit of context is ABC123. That's the same as the span ID of the parent that then created the next piece of work. So you can see that as we go along, the combination of these 2 values, trace ID and parent ID, allows us to be able to link together all of these spans to know that they're all part of the same request. And not only that, but also be able to identify the order in which they occurred. So it means we can trace back, based on those parent ID values, we can trace back and know, actually, this happened before, this happened before, this happened before this, which is what allows us to be able to gain that information to really pinpoint where things are going wrong. This is why context is so important. So with these 2 values, for any given operation, it's possible to determine the originating root service and to reconstruct all of the parent or ancestor services in order that led to that current operation. Okay, so that's the theory behind it. So we've got logs, we've got metrics, we've got traces, and we're focusing specifically on traces in this particular session today. So how do we enable that? We're using open source tools and technologies. So in the past, the way in which we would sort of instrument our code would vary. Each observability backend tended to have its own instrumentation libraries and agents for emitting data to those tools. The difficulty with this is that it meant there was no standardized data format, firstly. And if a company chose to switch observability backends, it means they'd have to re-instrument all of their code all over again to go to this new observability backend. So the community realized this, and it started to create open source standards. When it first started this, it created 2. There was Open Census and Open Tracing. So Open Tracing provided a vendor-neutral API to be able to send telemetry data to an observability backend. But the difficulty with open tracing is it required developers to actually implement that specification. Open Census, on the other hand, provided a language-specific library that developers could use to instrument their code and then send to any of the supported backends. Now, the difficulty with this is there's still two. That's not a standard. So the community, again, realized this and came together and brought the best bits of each of those specifications together and created Open Telemetry. So Open Telemetry is a CNCF project. It's actually the project in CNCF with the second largest number of contributors, only second to Kubernetes. So it's a really popular project, and there's lots of people working on it to improve it and utilize it. So it's really growing a lot at the moment. What it offers is this single standard. So being able to provide this way of having this high quality, ubiquitous, and portable telemetry into your applications. It offers a pluggable architecture that enables you to add various different technology protocols and formats very easily. It supports a lot of different open source projects, which is great, gives you that flexibility that you want. So it includes things like metrics format of Prometheus, but also things like tracing protocols used by things like Jaeger and Zipkin. So it means you're not forced down one path of using only one of those sort of back-end solutions. You can use Jaeger, you can use Zipkin, you can use Prometheus. It's really up to you as to which one you plug in to Open Telemetry. So lots of freedom and flexibility here. The way it works is a bit like this. So this is kind of a generic architecture you might find when using Open Telemetry. So you can see here on the left-hand side of my diagram, I've got the microservices within my application. I've also got some infrastructure that I'm running my application on, and I'm collecting telemetry data from those and sending them into my central collector. We'll come on to that in a minute. Once it's in the collector, we'll then send it across to any back-end systems that we might want to use to be able to do what I was talking about before, steps 2 and 3, storing, analyzing, visualizations. So you'll notice on this diagram, we have the acronym OTLP pop up a lot. We work in tech. It's like Latin. There's acronyms everywhere. Honestly, when I first joined, it was like everyone was speaking a different language. So OTLP, I try and make sure I define all of these. Shout if I don't. OTLP is short for Open Telemetry Protocol. This is the specification that describes the encoding, the transport, and the delivery of that telemetry data between different telemetry sources, intermediate nodes, and those backends I was talking about. So that's the OTLP, that's the specification for the transport of that data. The collector in the middle here is usually a vendor-agnostic implementation on how to receive, process, and export telemetry data. Normally, it's a single binary that can be deployed as an agent or a gateway. A bit more on the collector. What it really does is it helps to remove the need to run, operate, and maintain multiple agents or collectors, just have that central singular one. And it helps to improve things like scalability and supports lots of different open source observability data formats, like I was talking about Jaeger, Prometheus, FluentBit, the list goes on. You might be wondering, under what circumstances do I actually need to use a collector? Why can't I just send data from my source to the backend? And that's a valid question. For trying out and just getting started with Open Telemetry, if you're just trying it with a really small demo app, totally, forget the collector. Just send it straight from the source to the end. That's the easiest way to get started with a small development trial application. However, in general, we would recommend that if you're deploying this into a production environment or you're deploying this into quite a complex, large application, that you would use a collector alongside your service, because it allows your service to offload things like additional retries, batching, any encryption you need to do, sensitive data filtering. So it allows you to take that responsibility away from your individual service and offload that onto the collector and have that one single collector, rather than having to have lots of different ones for different agents. So we would recommend utilizing the collector. There is an Open Telemetry collector you can use as default. So that's Open Telemetry, but that is a specification. So you'll need an implementation to actually make use of it. So in Java, anyone a Java developer here? Yeah, a few hands. Nice, great, nice to meet you all. So Java developers, you'll be pleased to know that there is an implementation in the MicroProfile spec. just so I'm aware of where to pitch this, who has heard of MicroProfile before? Few hands, few hands. OK, not that many. OK. For those of you who've heard of it before, bear with me whilst I just give a brief introduction. For those who haven't heard of it, MicroProfile is a community-driven sort of specification that offers a lot of different key cloud-native Java APIs that build on top of Java EE, basically. So we had Java EE, that again got open sourced and became Jakarta EE. And the Jakarta EE community worked really closely with the MicroProfile community to help develop APIs that are needed and useful for Java developers who are trying to build microservice-based and cloud-native applications. So it includes a lot of different APIs, things like being able to have external configuration, CDI injection, JSON-B, JSON-P, and going up to things like having reactive in our applications, being able to have open tracing so that, and open telemetry and health checks and things like this. The nice thing about MicroProfile and Jakarta EE, and the two together, is that they have lots of different compatible runtimes. So it gives you that flexibility and freedom that others might not give you. So for example, if I'm a Spring developer, I'm kind of just using Spring, whereas by using MicroProfile, I can switch my runtime quite dynamically whilst they all support that sort of universal MicroProfile implementation. So less code changes and more community collaboration, which is nice to drive the strategy and forward sort of strategy for the specification. So right now, the latest, the very latest, is 7, which has literally just come out. So right now, there's only one runtime that allows it, and that's OpenLiberty. That's what I help work on, and right now it's only available in beta. But there's lots of others. So we've got 2, 3, 4, 5, 6, and lots of sort of less sort of minor releases within that as well. So in MicroProfile, there is an API called MicroProfile Telemetry. This was added in MicroProfile 6, and it adopts that open telemetry tracing to allow you to be able to make use of it in your Java applications. Now, the exciting news is that's just changed. So it's all changed. I've just updated my slides, so it's exciting. MicroProfile 7 came out, and that introduced Telemetry 2.0. So Telemetry 2.0 allows us to also adopt Open Telemetry's metrics and logs, as well as the tracing. Previously, we were just stuck with the tracing, and now we can implement all 3 of those key pillars of observability in Java applications. So that's super exciting. For anyone who is familiar with MicroProfile, that does mean that metrics has moved out of the standard stack and is now a standalone specification. So we would suggest starting to look at telemetry as a migration if you do use metrics. If you want more information on that, there is a really useful presentation, which I've linked to. I will share my slides afterwards if anyone is specifically interested in those changes that have occurred between Telemetry 1 and Telemetry 2. But given not many people know about MicroProfile, I'm just going to move on from that quite quickly. So when it comes to actually using MicroProfile telemetry in our Java applications, there are 3 different ways we can instrument our application. We've got automatic, which is, as you can imagine from the name, the least amount of effort. We've got manual, and then we've also got the Java agent. So automatic instrumentation. If you are already using Jakarta RESTful Web Services and MicroProfile REST client in your application, you can automatically enlist a lot of your services into tracing without making any code changes, which is really cool. If you're not using those, or if you want to make specific tracing in your application, you can use the manual instrumentation. This allows us to be able to use annotations like the @with span, or use CDI injection to be able to actually manually add that tracing in. If you're familiar with MicroProfile, you'll be familiar with the concept of using annotations, because they're used in pretty much all the MicroProfile specifications. And then the last one is agent instrumentation. So that's being able to use the Open Telemetry Java instrumentation project to, again, gather that telemetry data. And again, the nice thing is no code modifications needed, which is really cool. The way it works is a bit like this. So this is kind of how it's going to be for the demo application I'm going to hopefully show. So in this, we've got 2 applications coming together. We're trying to collect the context using spans and tracing from those microservices, sending them to our backend exporter to be able to actually view. Now remember, Open Telemetry, this whole thing is just that instrumentation step, step number 1. We still need to use additional tools like Jaeger, Zipkin, Prometheus, Grafana, Kibana to be able to store, analyze, and visualize that data, steps 2 and 3. So we'll show that in the demo as well. So, on to demo time. Okay, so this demo is using Open Liberty. Anyone heard of Open Liberty before? I'm expecting even less hands. Oh, a few, great. Excellent, that's like a pleasant surprise. Okay, anyone heard of WebSphere before? Oh, a lot more hands, shocker. Okay, so WebSphere is sort of our older product, more traditional, kind of large, kind of bulky, kind of not really great for cloud native development. So what we did is we basically took the concepts of WebSphere and we decided to start again and create Liberty, which offers a lot of the same features and functionality, but in a modular fashion. So it's really built for cloud-native applications and built so that you can just plug in what you need to make it as lightweight and as performant on the cloud as possible. Then in 2017, we open sourced that, and that's how we got Open Liberty. So you can try it out if you want to. You can check out, I'm biased because I wrote it, so you don't have to check it out if you don't want to. But if you want to check out the article I've written, like why people love Liberty and the performance benefits, you can visit this link and find out more about it. We're quite proud of the fact that we've been working quite hard on trying to make sure that it's easy to use, and part of that has been making these interactive guides. So these are free on our website. We've got over 60 different guides. Lots of them cover the MicroProfile and Ducati EE specifications. So if you're interested in finding out about any that I'm not covering in this session, then do go and check out our guides, and we'll usually have a guide on them. The nice thing about this is that most of these guides work in our new environment, which is a browser-based IDE. So it means you don't even need any prerequisites on your local machine. You can just go and use a browser. It's a Thea-based IDE. It's got all the instructions and allows you to do all the steps within a browser-based environment. So that's hopefully what I'm going to use today. OK, I'm going to have to stop that and then switch. Excellent. OK, can you see this? Nod? Yeah? Is it big enough? Yeah? Excellent. Cool. So as I said, this is a guide you can do yourselves. So the way I got there was just going to the Open Liberty website, going to the guide section here. We've got a menu on the left-hand side, or you can search for stuff that you're interested in. So I'm going to do telemetry, if I can spell. I can't spell. Do you know what? I'm jet lagged, and we're just going to go to observability. So here's the guide I'm doing. You can see this button says Running Cloud. That's when you know you can use our Running Cloud sort of IDE. It will take you through to a page that looks like this. If you want to do it locally on your laptop, you totally can. Just make sure that you're looking at the prerequisites and make sure you have those before starting. And you can follow the instructions here in this environment. Or click the Running Cloud option. It will ask you to log in. We didn't have a login before, and Bitcoin miners discovered that. So we now have a login. But we have lots of different ways to log in. Social logins, GitHub, or you can just create your own account. So hopefully, we're all developers. We've probably all got a GitHub account of some kind, if not social, LinkedIn, that kind of thing. So you should be able to log in. And then it will take you to this environment where, as I mentioned, it's this Thea-based IDE that we're using. So on the left-hand side, you'll see the instructions. On the right-hand side, this is sort of our IDE. And then we've got our terminal at the bottom here. Now, in the interest of time, I've already run through the setup of this lab. So if I go back to the very beginning, in all our labs, we'll give you an introduction as to what we're covering. We'll also give you an introduction about what you're going to learn with a diagram. Most of our labs use the same application, so it makes it really easy to be able to do multiple different guides. You've got the inventory service, and you've got the system service. The inventory microservice is just scraping inventory on your computer, on your system, every 15 seconds. The system microservice is storing a list of that from the inventory microservice. So we use the same one in all of them. What I've done is I've cloned the repo. It's available freely on GitHub, so feel free to go and check them out. They are all open source. We've got some Docker commands here to set up our Jaeger for that backend system, which you can see running here, which I've already got set up. And then I skipped all of this because that goes to our finish directory. In all of our guides, we have a start directory and a finish directory. If you don't want to go through all the steps and you want to cheat and just go to finish, you can if you want to. That takes you to the very end of the guide and shows you what you should get to right at the end. The start directory is where we start and then follow all the instructions, and by the end, we should have it should look exactly like the finish directory. So in this, I'm not going to go through the finish directory. That would ruin the surprise. So instead, what I've done is gone into start, and then I've started my 2 microservices. So in this case, in all our guides, we're using Maven. That's not to say you can't use Gradle. You absolutely can. You can also use Ant if you really want. Your choice. Not going to judge. But we're using Maven in this just to make it simple so that we have the same build tool and you don't have to relearn different build tools in all the guides. So in this case, I've started my application, my 2 microservices, with Liberty's dev mode. Liberty's dev mode basically allows us to be able to start Liberty and have it constantly listening for code and configuration changes. So it's like a hot reload, basically. So instead of having to tear down my whole application and restart it again, rebuild it, every time I want to see my code change, instead it automatically rebuilds any classes that have been changed and edited so that I can see them in real time. So it makes things like this a lot quicker. So I've already got the inventory and the system microservices up here running. You know that they're up and running in dev mode when you see this lovely message, Liberty is running in dev mode. So I know that both my microservices are up and running. What else I've done? I've done some curl commands to sort of make sure that the system and the inventory microservices are up and running. So now we're at the stage where we're actually getting into the nitty-gritty of this lab. So the first step in this lab is the automatic instrumentation. So to do this, as I mentioned, my application is already making use of Jakarta REST and MicroProfile REST client. So I can automatically enlist those services in tracing without any code changes. To do this, all I need to do is make sure that MicroProfile telemetry is enabled in my configuration files. So I'm going to open up my server.xml. Again, we've tried to make it really easy to use by making sure that these buttons are interactable. So you can go and manually find it yourself if you want in the Explorer view, or you can just click this button and it'll open it for you. So I'm going to copy and paste all of this over and make this a bit bigger so you can see it. So you can see in my configuration, what I've done is, all I've done is add this MicroProfile telemetry feature so I can start to make use of it. Do remember to save in this environment because it does not automatically save for you. So that first server.xml was for the system microservice. This second one is for the inventory microservice. And as you can see, it's just adding this extra line to enable that feature for MicroProfile telemetry. Now, weirdly, and I really don't know why this is, I should probably find out at some point, weirdly, MicroProfile tracing is by default off. It's kind of weird. So you have to actually turn it on with some config. So what we're going to do is create that config. So we're going to run this touch command. This will create a MicroProfile config properties file, which allows me to be able to separate my config from my code. So that's another API from the MicroProfile specification that I'm using there. So in this is for the system microservice, as you can see from the name I've put into my configuration here. What I'm doing is just setting OTel SDK disable to false, and that turns tracing on. So that's what I need to do for both of my services. So we already have it, because we already have some configuration in there for the inventory microservice. So I'm just going to replace that with those additional pieces of configuration. And now all I need to do is run the curl command. And now I can go back to my Jaeger service. So I'm just going to refresh here. And now what we'll see, hopefully, if the Wi-Fi works, yeah, great, is if I find traces, perfect. Without making any code changes, I went from having 0 tracing to now having 3 different spans in a trace that I can get access to. And I can dive into that and start to get some of the details. So you can see it's really useful for being able to automatically enlist without making any code or configuration changes. Now, in the interest of time, I'm not going to run through the following 2 sections. But if you're interested in looking at the manual instrumentation, so that's adding it in those annotations to manually add in tracing to your application, or if you're interested in the Java agent instrumentation, then do check out the rest of this lab. It runs you through what you'll need to do to add that in. If I go right to the bottom. And then right at the end, we've got just some tests to make sure our application's working correctly. We've already set them up for you. In dev mode, to run the tests, as you can see, my application has been if I go right to the bottom, has been updating as I've been saving and making those changes. So I haven't need to tear down my application and restart it because I've had it running in dev mode. In here, all you need to do is hit enter to actually run those tests. So if you want to have a shortcut, you can do that and check out if the tests run successfully or not. So right now, they are passing, which is pretty cool. Once you make all those changes, they should hopefully pass. If they don't, check out the finished directory and compare to see where you might have gone wrong. Do make sure to clean up your environments with this Jaeger stop and the sort of scripts that we have at the end to remove those files, because if you go onto another guide, it will save all your progress. You'd need to completely log out to clear your environment, so just bear that in mind. We do have cleanup scripts for you. Okay, so with that, I had a video just in case the Wi-Fi didn't work, but luckily we were sort of lucky with that. Play from Scar inside. Cool. So, oh, and now my laptop's frozen. Oh dear, wheel of death. I'll just summarize myself. So, in summary, hopefully what I've shown you today is that we are entering into a world of increasing complexity. We can learn from the world of biology and medicine, and hopefully learn that when it comes to our own applications and effective observability, really context is critical for us to have, and we can start to enable that with the addition of tracing to our arsenal of logs, metrics, tracing, all of this great observability data. But the nice thing is, you're not alone. There are open source tools available. If you are not a Java developer, there are other language implementations of the Open Telemetry specification. So don't panic and think that you can't use this. You absolutely can. You'll just need to use an implementation in the language of your choice or runtime of your choice. But yeah, Open Telemetry is there to hopefully help us make this a lot easier and enable that observability. In case I haven't given enough links and resources and homework already, there's more, because who doesn't love observability? So if anyone wants some additional resources, there's some here. Again, I will share my slides afterwards. And if you'd like to learn more about OpenLiberty, which is, again, the runtime I work on, feel free to connect with us on LinkedIn or Twitter. I run the account, so I'll say hi. And we'd love to hear your feedback if you have any on the guides, if you do happen to have a chance. So with that, I'm going to say thank you so much. If I don't get around to any questions that you have today, please feel free to reach me during the conference or on Twitter or on LinkedIn. And if anyone is still around tomorrow, I have another session. Come join. We're going to be talking about cloud-native dev tools for productivity. So check it out if you're interested. If not, I'll see you at the party tonight. Thank you very much.